Alright, I forget where I left off because my video stopped. I hit my 15-minute mark. So, we used our test point, 0, 1. We knew 0, 1 was inside of the parabola. The test point came back false, so we had to shade everything on the opposite side of the parabola. So we shaded everything on the outside of the parabola. Example 3, let's graph an inequality, or graph a quadratic inequality, where we'll have to shade the inside of the parabola. So I already did the vertex for you right here, the equation for the formula for the vertex, negative b over 2a. I found the value of x, which was negative 1, plugged that negative 1 back into the original equation, and found the value of y, which was 4. That gives you the coordinate for our vertex as negative 1, 4. So that is right up here, negative 1, 4. You can check from the already graphed parabola on the notes that you are correct. Now we know that the parabola uses a solid line because the inequality is less than or equal to, and the parabola will open down because a is negative. Now you'll notice the difference between the example up here and the example down here. We are going to go with the example down below, and I'm going to make this an equal to. Not with that. Let's try that. There we go. We'll make that an equal to. So the equation is, or the inequality is, y is less than or equal to negative x squared minus 2x plus 3. We will be using a solid line to graph our parabola, and the parabola will open down because a is negative. Now if you look at this quadratic inequality, you can see that it is in fact factorable. So instead of doing that whole quadratic equation thing, you definitely can if you would like to. Let's just factor this. We'll take out that negative 1, which gives us x squared plus 2x minus 3. The factors of negative 3, that will give us positive 2, are 3 and negative 1. So when we find our roots, we have to do the factored form of this equation, which would be x minus 1 times x plus 3. X minus 1 equals 0, x plus 3 equals 0, so x equals 1, x equals negative 3. So our roots are 1 and negative 3, and here they are. We are correct. There we go. Okay, now this time we can use the point 0, 0, which is great. I love using the point 0, 0. And we know 0, 0 is inside the parabola. So when we do our test point, we plug in 0 for y and 0 for both x's. We are going to get 0 is less than or equal to 3. 0 is less than or equal to 3, which is true. 0 is less than or equal to 3, so we are able to shade the part of the parabola that contains 0, 0, which is on the inside. Checkpoint! Alright, this is the last thing. When you are ready, pause the video. Make sure that you are able to find the vertex, find the roots using factoring or the quadratic equation, and shade appropriately to match the example. I'll be here when you get back. Welcome back. Checkpoint number 5. We found the vertex, You graph your vertex. Then determine whether or not it is factorable, or just use the quadratic equation if you'd like, or the quadratic formula. Found that it was factorable, so we were able to do our two binomials to represent our roots, and found the value of our roots, graph the roots. Use the test point 0, 0, because the parabola is not on 0, 0. We found that it was false. 0 is not greater than 4, it is false. So we had to shade everything on the outside of the parabola, because 0, 0 is on the inside. Number 6, same steps. Find the vertex, factor, or use the quadratic formula to find the roots. We use the test point 0, 0 again. 0 is not greater than or equal to 3, so this one was also false. So we had to shade everything on the inside of the parabola because 0, 0 was on the outside. And there you have it. Quadratic inequalities.